Okay, so this is going to be our lesson on reading the periodic table and finding protons, neutrons, and electrons. So write this down with me. The first rule is that the number of protons is equal to the atomic number on the periodic table. For an atom, the number of electrons is equal to the number of protons. And the number of neutrons is equal to the mass number minus the number of protons in your atom. And that's because the mass number, which is the weight of the nucleus, is equal to the protons plus the neutrons. So these are the rules for solving all the different parts of the atom. Now let's go over and take a look on the periodic table. If you haven't finished writing it down yet, you can pause right now, but let's look at the Okay, so the next step is to look at the actual periodic table. This is the same one that we use inside of class. You can see it has all the different elements listed through it, arranged by atomic number, which means they are arranged by number of protons. Now, some periodic tables are slightly different in the information they provide, but they are all organized the same way. When you encounter a periodic table, one of the things you want to look at is the key. So if I zoom in on the key here for our periodic table, it tells us how it's organized. They use sodium here for an example. It tells us that the atomic number is at the top. So the atomic number of sodium is 11. It gives us the element symbol, which is Na, and the name of the element underneath it, which is sodium. Now the one thing that's a little bit different for us is they give an average atomic mass, which is not uncommon, but we are going to round this. So if you see 22.99 for an average atomic mass, you would round that up to 23. We only want whole numbers. So if you see something 0.4 or less, you're going to round it down. And if you saw something 0.5 or higher, you're going to round that up. So if we look at the rest of them, now is where we start to figure out protons, neutrons, and electrons. So let's take a look at vanadium. Vanadium is just any example. All the elements on here work the exact same way. So the first thing I want to identify is what's my atomic number. So for this atom, the atomic number equals 23. So now the other thing that might come in handy is the mass number. And if the mass number is 50.94, then I will round that, and I know that the mass number equals 51. Now from there, I can figure out everything else. If you remember back to our last sheets, we knew that the number of protons equaled the atomic number. So in this case, the number of protons is going to equal 23. The number of electrons was equal to the number of protons. So again, that will equal 23. And the number of neutrons is equal to the mass number, which we have over here, minus the number of protons, which we have over here. So for my case, we will have 51 minus 23, which is going to equal 28. So the number of neutrons equals 28 for vanadium. And that's going to be done the same way for every single element. Let's try one more example on the next page. We will look at lithium, which is 3 and 6.94. So here's another example for lithium. You can see I've arranged everything inside this box just how it was inside of our periodic table. So the top number 3 is going to be our atomic number. We have our symbol for lithium, Li, and our mass number 6.94. So if I am trying to solve for the different parts of the atom, the number of protons, number of electrons, and number of neutrons. So we said the number of protons right here was equal to our atomic number, which is over here. So that means I have 3 protons in this case. and we said that the number of electrons were equal to the number of protons. So again, I have 3 electrons, and finally the number of neutrons was equal to the mass number rounded, so this will round to 7 minus the protons. And if I do 7 minus 3, this will equal 4 neutrons. Okay, so let's just say you have a worksheet or you have some experiment you're doing and you know only the number of protons in an atom and its mass number, and you are asked to find everything else. Even though you only know these 2 pieces of information, really you can solve for the electrons, the neutrons, and the atomic number. If you go back to our rules, we said that the atomic number was equal to the number of protons. So that means for our element, the atomic number equals 18. And if you go back to the periodic table and you look up number 18, you'll find out that argon is your element there. And if you're trying to solve for electrons, we said that the number of electrons is equal to the number of protons. So therefore, the number of electrons is equal to 18. And finally, the number of neutrons is equal to the mass number, 40, minus the protons, 18. So the number of neutrons here would equal 22 neutrons. Every problem is some variation of this, but this is probably one of the harder ways to do it. If you have any other questions, make sure you see Mr. Olandisi or stop by the Academic Center during lunch, and one of the National Honor Society tutors can help you there. Good luck.